2016. The Hubble Space Telescope turned toward a dark patch of sky in the constellation Ursa Major. It captured an image of an indistinct blob of light. The glow is from a distant galaxy called GNZ11. The most distant galaxy we've ever observed. But is this the edge of the universe?
The universe all around us is filled with galaxies, so it's kind of natural to say, would there be a final galaxy? If you traveled far enough away, would you finally be at the very last galaxy in the universe, looking out into empty space?
That's a difficult question to answer, because there's a limit to how far we can see. It all comes down to the speed of light and the age of the universe.
The key to understanding the edge of the universe is that light travels very, very fast, but not infinitely fast. It takes time for it to get from one place in the universe to the other.
You open the curtains, light fills the room. It doesn't seem to travel at all. But over the vast distances of the universe, you actually notice this travel time. Even the sun, 93 million miles away, the light takes 8 minutes to get to us.
When you look out at the stars, we start to think of distance in terms of light years, because it takes years for the light to get from those stars to us. And then when you look at galaxies, then you're talking about millions or billions of light years.
When we look at the light from galaxy GNZ11, we're seeing light emitted 13.4 billion years ago.
You can't really even find a galaxy too much farther away than that, because the universe is only 13.8 billion years old, and it takes a certain amount of time for galaxies to even form. So we're not going to find too many more galaxies farther away than this.
If things are far enough away, there is no way that light can get to us in the age of the universe. What this means is there's a hard limit to the edge of the universe that we can see, and this is set by the age of the universe.
GNZ11 sparked into life early in the history of the universe, just 400 million years after the Big Bang. Before that, there were no stars to send out light.
If you look in any direction at all, you get all the way back to when there were no stars, no galaxies, nothing but very, very hot gas. And that sort of forms a shell around us.
That outer shell is the cosmic microwave background. It is the oldest light in the universe, the echo of the birth of the universe, the Big Bang.
The edge of our universe, the very furthest thing that we can see, is one of the earliest relics of the formation of the universe itself. That is the cosmic microwave background.
We call this the edge of our observable universe.
So we have an observable universe, but beyond that, even if there are things out there, there's no way we can see them because the light just could not have gotten to us by now.
As the name states, the observable universe is simply the part of the universe we can see.
We can think of the observable universe as sort of like a spotlight centered on wherever you're standing right now, and you can see to the edge of your spotlight and not beyond. But if you move a little bit to the left, a little bit to the right, your observable universe actually moves with you.
For someone living in galaxy GNZ11, a totally different part of the universe would be observable.
So that distant galaxy is at the edge of our observable universe, and we are at the edge of their observable universe. We have different spotlights.
One of the wonderful things to think about is that there are other spheres around other galaxies. There are other aliens looking up into the sky tonight, wondering what the true extent of the universe is.
The true extent of our universe doesn't end with galaxy GNZ11. But when astronomers use the Hubble Space Telescope to accurately measure the distance to GNZ 11, they find something shocking. It's 32 billion light years away, 3 times further than thought possible.
So if nothing can travel faster than light, and we measure the distance to this galaxy, how can it be 32 billion light years away?
There hasn't been enough time in the history of the universe for light from GNZ 11 to reach us. There must be some mistake here, right?
At this point, your brain is probably thinking of leaping out of your skull and running around screaming. Trust me, I know. I'm an astronomer. I've been doing this my whole life, and this stuff twists my imagination up. It's really hard to grasp this.
How do we see a galaxy that's 32 billion light years away and only 13.4 billion years old?
GNZ 11 is further away than it should be, because something strange is going on with our universe. It's expanding. And if the universe is expanding, then where does its edge lie? And can we ever reach it?